In 2024, Google unveiled a quantum computer called Willow that completed a calculation in less than 5 minutes. A calculation estimated to take one of the world's most powerful conventional supercomputers around 10 septillion years. That's a 1 followed by 25 zeros. For context, the universe itself is only around 13.8 billion years old. So it would have taken one of the most powerful traditional computers vastly longer than the universe has even existed to solve. Now I should point something out. This particular calculation was designed specifically to test a quantum computer. It wasn't curing cancer, predicting the future, or designing the perfect car. But it did demonstrate something extraordinary, that we've started to build new machines capable of performing certain calculations in ways that conventional computers may always struggle to compete with. And if these machines continue to develop, they could eventually affect everything from medicine and artificial intelligence to cybersecurity and energy. They could even impact our understanding of reality itself. So what actually is a quantum computer? Why do they need to be kept colder than space? What exactly might they be capable of doing? And because this is layered future, I'm going to explore why all of this might eventually matter to you. Honestly, this is really fascinating. So enough of the intro, let's dive in. To understand why quantum computers are so odd, you only really need to understand one thing. Every normal computer, from an old ZX Spectrum to the most powerful supercomputers on Earth, works using tiny switches called bits. Each bit can be either a 0 or a 1. That's binary code, which no doubt you've heard of. Now, put billions of those switches together and you can create everything we use and see in the digital space, from YouTube videos like this to artificial intelligence. But a quantum computer works differently because instead of bits, it uses qubits, and that's where things get a bit weird. A qubit doesn't have to behave like a simple switch that's definitely a 0 or definitely a 1 while a calculation is taking place. Instead, quantum physics allows it to represent a mixture of different possibilities. And when you add more qubits together, the number of possibilities the machine can work with grows incredibly quickly. Quantum computers then manipulate those possibilities so that wrong answers tend to cancel one another out and useful answers become more likely to emerge. They don't just try every possible answer at once, which is sometimes how quantum computing is described. It's more like giving a computer an entirely different mathematical landscape in which to search for an answer. And for certain kinds of problems, that can make a massive difference. In fact, that's an understatement. This is why quantum computers aren't just really fast versions of normal computers. They're computers that calculate in a very different way. There is a problem though, and that's that qubits are ridiculously delicate. Heat, vibration, and in fact, any kind of interference from the outside world can disturb them and ruin a calculation. So some quantum computers have to be cooled to stupidly cold temperatures, and I mean only a fraction of a degree above absolute 0 stupidly cold. You can't achieve that with a few fans. It's colder than deep space. We've essentially had to create some of the coldest places in the known universe just to keep these strange new computers working. So quantum computers look quite unusual. The enormous golden structures that sit around them are mostly refrigeration equipment designed to protect the tiny, really small quantum processor sitting inside. Anyway, that's a bit about how they work. But what really interests me, and I'm sure you as well, is what they might be capable of actually doing. Well, they promise an awful lot, and great things could happen once we've mastered this new technology. But there are also some issues of concern. Okay, let's get the bad stuff out of the way first, because quantum computing does pose some challenges to the world as we know it. The main problem that might arise relates to encryption. Most of the security protecting the modern internet relies on mathematical problems that are incredibly difficult for conventional computers to solve. Given enough time, a normal computer could theoretically crack the heavy encryption that we already use, but the numbers involved are so enormous that trying would take a ridiculously long time. But a sufficiently powerful quantum computer changes that equation. Certain quantum algorithms could massively reduce the difficulty of breaking some of the current encryption systems that protect banks, governments, communications, and our private information. But look, I'm not here to worry you. Nobody's going to turn on a quantum computer tomorrow morning and unlock the entire internet. The quantum machines that exist are nowhere near powerful or reliable enough yet. But the threat is taken seriously enough that governments and technology companies are already moving towards new forms of encryption designed to survive quantum computers. There's even a rather worrying cyber threat strategy known as harvest now, decrypt later. The idea is really simple. Bad actors steal encrypted information today, store it, and then wait for quantum computers powerful enough to decrypt it. So clearly that is a worry, but the things quantum computers might break are only half the story. I think what they might allow us to solve is equally important and exciting. That's because nature itself works according to quantum physics. Atoms, electrons, and molecules all follow quantum rules, which currently makes accurately modeling complicated chemistry extremely difficult using traditional computers. But a quantum computer would be using quantum physics to model quantum physics, and that could eventually allow scientists to understand molecules and materials in ways that are currently extremely difficult, almost impossible. Importantly, this isn't a theoretical progression in computer technology. Google has already demonstrated a quantum algorithm on Willow and says it ran around 13,000 times faster than the best classical approach, with potential applications in studying molecular structures, new medicines, new battery technologies, new materials, more efficient energy systems. The list of potential benefits is long. They may also provide solutions to scientific problems that we currently have to intentionally simplify because our computers can't cope with the complexity of reality. However, if you're sitting there excited about one day owning a quantum computer, then I'm sorry, I'm going to have to disappoint you because this technology probably won't replace the computers that you or I use in everyday life. You're unlikely to be buying a quantum laptop anytime soon. Instead, they're probably going to be used as specialist machines called upon when a particular problem becomes too complicated for traditional computing. A kind of super tech sitting in the sidelines ready for when only extreme computational power will do the trick. Because we've now entered the AI revolution, we have to talk about artificial intelligence in relation to quantum computing. AI has already become hugely powerful, partly because we've given machines access to massive amounts of data and enormous quantities of computing power. So quantum computing will introduce an entirely different form of computation into that equation. Researchers are already exploring whether quantum algorithms could eventually help with particular areas of machine learning, optimization, and scientific modeling. To be clear, that doesn't mean that plugging ChatGPT into a quantum computer will suddenly make it 10,000 times more intelligent. In fact, it may not work like that at all. But quantum computers may become exceptionally good at solving some of the problems that AI systems struggle with. And at that point, two of the most powerful computational technologies we've ever developed will start feeding into each other. Plus, AI could potentially help us design better quantum systems, discovering really useful applications for them. Quantum computers might then, in return, give future AI systems access to types of calculation that conventional hardware would struggle to perform. And that may be the point that quantum computing becomes particularly relevant to ordinary people like you or me. Not because we'll own one, but because quantum computation will begin driving our medicines, our materials, and our technologies, plus the intelligent systems we use. As a comparison, most of us today never interact directly with a supercomputer, and yet supercomputers already influence weather forecasting, medicine, engineering, climate modeling, and scientific research. So eventually quantum computing could become an exceptionally powerful layer that sits underneath society. Except this technology is one that operates according to rules so strange that physicists still disagree about what those rules actually tell us about reality. Perhaps the strangest part of quantum computing is this. We know the mathematics works and we can build these machines, run experiments and measure results. But physicists still disagree about what's actually happening beneath the surface. One interpretation of quantum mechanics is called the many worlds interpretation. In very simple terms, it proposes that all of the different possibilities described by quantum mechanics may actually exist across different parts of reality. Some physicists, including David Deutsch, have argued that quantum computing fits naturally within this view. Google's researchers have even referenced that idea when discussing the extraordinary performance of their quantum processors. Look, this doesn't mean that quantum computers have proved the existence of parallel universes, but it does mean that we're now building machines whose behaviour we can control without being able to agree on what that behaviour ultimately represents. And I find that absolutely extraordinary, hugely exciting, and just a little bit concerning. The first computers gave us machines capable of manipulating information. Then the internet connected that information. Now artificial intelligence is becoming increasingly good at interpreting that information, and quantum computing may soon give us access to an entirely new way of processing it. I think the most important thing to take away from this video is that quantum computers represent something wildly different. They don't just promise more power, they promise more possibility. And if they eventually work at scale, some of the problems we currently see as impossible may be solved. And so that's why quantum computers matter. They're yet another technology that will almost certainly shape the decades to come. As always, thank you so much for watching. I look forward to seeing you again in the future.